Hi, how's everyone? Mr. Jorgens here. Wish we could be in school together, learning about this stuff and getting to interact with each other. But since we can't, at least I'm going to take this opportunity to talk to you guys again about two-step equations. I'm going to call this one 1.2 Solving Two-Step Equations Part 2. All right, so stay tuned. There's going to be a few questions for you to solve along the way. Check this out. Our goal for today is to add in two rules that you learned in your past for math that we're going to add into our solving equations techniques that we talked about yesterday. The first rule is called the distributive property. Some of you may think of it as the rainbows. What the distributive property says is if we have a number, let's call that number A, multiplied by something in parentheses that's either added or subtracted together, let's say B plus C. Then what we can do is we can multiply that A by both the numbers on the inside and get A times B plus A times C. Now I know that's a little bit abstract, but I think a lot of you have done it before. Let's look at an example of this. My first example of this would be something like 3 multiplied by 2x minus 7. Now what the distributive property says is I can multiply that 3 into both parts. And when I do that, the parentheses will go away. So what I can do is I multiply my first number, my a, which a in this case is 3, multiplied by 2x. And if I multiply 3 times 2x, I get 6x. 3 times 2 makes 6, and then I have an x there. Then I can multiply by 3 to my negative 7. That would be my a times c from the general formula. When I multiply 3 times negative 7, I'm left with a minus 21. So by the distributive property, I can say that 3 multiplied by 2x minus 7 is equal to 6x minus 21. Before we move on to the next screen, I want you to try one problem just to make sure that you feel comfortable with it. Work it out in your notebook. 5 multiplied by 4x plus 6. Go ahead and try that one. Okay, hopefully you got that one right. Again, just to check our answer, we would multiply the 5 times 4x to make 20x, and then we'd multiply the 5 by a plus 6 to make a plus 30. So we'd end up with 20x plus 30. Hopefully that's what you got. The other topic that's going to come up from your past junior high math today is something called combining like terms. And this is something that we're going to need to do as well with the distributive property when we're looking at some of these more complicated equations. The main reason why we would want to combine like terms is if we were looking at an equation with many x terms and many number terms that wasn't simplified. And if the equation's not simplified, it's going to be a lot of steps to solve it by our process of inverses. So it's easier to simplify the equation first and then go about solving it. Before we start looking at equations with like terms that need to be combined, let's just look at some expressions with multiple x terms and multiple numbers terms that need to be simplified in order to make the equations later on down the road easier to solve. One example of that would be if I had 2x plus 7 plus 5x minus 3x plus 11. As you can see, there's a lot going on here. So if I were to solve an equation with all of these parts, there would be a lot of things to undo, and it would be easy to get confused. However, if we combine like terms first, this problem will actually become quite simple. Now, the way we combine like terms is we look for all of the x parts and all of the numbers parts and then combine them separately. I'm going to start with the x's. Your junior high teacher may have drawn shapes around the x terms or may have drawn a certain number of lines underneath. I like to take my first category and I'm going to single underline all of the x's. So my first category, the x's, I'm going to single underline those 3 terms in blue. And the reason why those are one category is because all three of those terms have an x in it. Next, I'm going to look at my other category, which is just the numbers. For this category, I'm going to double underline those terms in red to show that they go together. I can combine x's with x's and I can combine numbers with numbers, but I can't combine an x term with a numbers term. Thinking about my x term, I have 2x plus 5x minus 3x. And I can just go ahead and combine those coefficients. So 2 plus 5 makes 7, and then 7 minus 3 is going to make 4. So the amount of x's I have is 4, because I have 2 plus 5 makes 7, subtract 3 makes 4x. Next, I'm going to look at my numbers term. And in this case, I only have two numbers term, which is the double red underline. I have 7 plus 11, and 7 plus 11 makes 18. So I have 4x plus 18. Now, this is going to make an equation a lot easier to solve, because instead of 5 different terms with 5 different numbers to undo, now I'm just left with 4x plus 18. So if I had an equation, I would then just have to subtract the 18 and divide by 4, and I'd be done. Combining like terms is going to be a big technique to help us solve equations that look messy in a way that's more simple. I want you to try one combining like terms problem on your own. 3x minus 7 plus 11 minus 2x plus 4x minus 3. Go ahead and try that one on your own. Okay, go ahead and check your work here. Hopefully you got it right. First, I'm going to look at my x terms. I underlined those in blue. 3x minus 2x makes 1. 3 minus 2 is 1. And 1 plus 4x will make 5x. So on the blues, 3 minus 2 plus 4 makes 5. And then if I look at my red terms, negative 7 plus 11 makes a positive 4. And positive 4 minus 3, my other red term, is going to make a plus 1. Hopefully we know how to combine like terms. If we can do the distributive property and we know how to combine like terms, and we combine that with what we did with equations yesterday, we're going to be able to solve some equations that look pretty tricky. Let's try one of those. All right, here it is. Example, we got 42 equals 9x minus 6x plus 15. Now this problem is going to be similar to the equations we solved yesterday, but it's going to have one extra thing in it. Before we start this problem, the first thing you're going to have to ask yourself is, for this problem, would I have to use the distributive property or would I have to use combining like terms? Those are the two techniques we've covered so far. So before we start it, let's think to yourself for a second. For this problem, would I have to do the distributive property or combining like terms? Hopefully you realize that this one is going to be combining like terms. The reason why it can't be the distributive property is I don't have any parentheses. Remember that the distributive property, we had the rainbows going into the parentheses. Combining like terms is when we had two different x parts or two different numbers parts. In this case, on the right-hand side of my equation, I have two different terms that have an x in them, 9x and minus 6x. So before I go to solve my equation, I'm going to be able to combine that like term. In this case, combining the like term, 9x minus 6x, makes 3x. I can write down the rest of the equation as is because I didn't change anything there. And when I do that, I'm left with 42 equals 3x plus 15. And this should look exactly like the two-step equations that we worked on last time. If I want to get x by itself in an equation like this, I'm going to need to move the 3 and the 15. If you remember, we undo PEMDAS going backwards. So think to yourself for a second. Which would I move first, the 3 or the 15? And hopefully you thought the 15, because the 15 isn't adding and subtracting. That's lower in my tree of PEMDAS than the 3, which is stuck by that invisible multiplication dot. So the first thing I'm going to do is undo add 15 by subtracting 15. off of both sides. 42 subtract 15 makes 27. Add 15 and subtract 15 on the right-hand side are inverses, so they make 0, and I'm just left with 3x on the right-hand side. Next, I need to undo my multiply by 3. And I can undo multiply by 3 by dividing both sides by 3, because multiply 3 and divide 3 are inverses. When I do that, 27 divide 3 makes 9. And 3x divide 3 divide 3 makes 1x, or just x. So I'm left with my answer of 9. Another problem that we can work on now that we've discussed the distributive property and combining like terms is one like this example. 2 multiplied by parentheses 3x plus 9, close parentheses, equals 12. Now, if we're going to work on this problem, we either are going to have to use the distributive property or combining like terms first. So think to yourself, which would you use, the distributive property or combining like terms? Hopefully you realize this one is the distributive property. If you see a problem with parentheses, that should be a really big key or tip or hint that in this problem you're going to be doing the distributive property. So we see those parentheses and I can multiply in. So 2 multiplied by 3x makes 6x. And 2 multiplied by a positive 9 makes a plus 18. So I'm left with 6x plus 18 equals 12. Now that I've simplified the left-hand side of the equation using the distributive property, the problem is set up to solve using my techniques for solving two-step equations. In this problem, I have two numbers that need to be moved, the 6 and the 18. Again, my strategy for solving these equations is to undo PEMDAS in reverse. So in this case, I have 6, which is stuck by an invisible multiplication dot, and I have 18, which is stuck by addition. Which number am I going to move first? So this is big. Hopefully you realize I keep asking questions on this. It's really important that you know which number to move first, right? We need to move the two numbers on the same side as x, but is it going to be the 6 or is it going to be the 18? In this case, 18 is lower in that tree of PEMDAS, so I'm going to move it first by subtracting 18 to both sides. When I do that, 12 subtract 18 is a little bit of a tricky one because the bigger number is negative. What we talked about in that first day is when you're stuck on a subtraction problem, making a plus-minus chart. In this case, 12 is positive and 18 is negative. So then I have to ask myself the question, is there more positives or more negatives? And in this case, there's more negatives, so my answer is going to be negative. And then how many more? So in this case, 18 is 6 more than 12. So I have 6 more negatives than positives. So my answer is going to be a negative 6. 12 subtract 18 makes negative 6. On the left-hand side, plus 18 and minus 18 are inverses, so they cancel, and I'm left with just 6x. Now, all that's left to do is undo my multiply by 6, and I can do that by dividing both sides by 6. 6 divided by 6 makes 1x. They're inverses, so multiply 6 and divide 6 undo each other. And then on the right-hand side, negative 6 divided by 6, a negative divided by a positive, based on my multiplication triangle. A negative divided by a positive makes a negative. And 6 divided by 6 makes 1, so I'm left with negative 1. We looked at some more complicated equations today, using the distributive property and combining like terms. We'll continue with this tomorrow when I see you live in the Google Meet. Hopefully you have a good day, and thanks for watching.